Welcome all my dear student of TYBSc physics class. Today we are going to start new chapter of this fourth paper electronics, and the chapter number is also 4, and the title of the chapter is applications of operational amplifier, that is applications of the OpAmp. You already studied the first part of this chapter in SYBSc. In SYBSc, you studied the definition of OpAmp, then virtual ground, then OpAmp as a inverting inverter, OpAmp as a non-inverter, and you also studied two applications of OpAmp, that is OpAmp as a adder and OpAmp as a subtractor. Now in TYBSc we have to study the remaining part of the operational amplifier, that is applications of operational amplifier. Though we are studied in SYBSc, but here I am going to briefly take the review of that syllabus also. So what is OpAmp or what is operational amplifier? Operational amplifier, sometimes called abbreviation of operational amplifier, is OpAmp. OpAmp is a voltage amplifier. OpAmp is a voltage amplifier usually consisting of two inputs and have a single output. Out of these two input is inverting input and another is non-inverting input. Okay. So I told you that an OpAmp is a voltage amplifier usually consists of two input terminal, one of them is inverting terminal, another is non-inverting terminal, okay, and has a single output. Remember that it is a DC coupled negative feedback amplifier. It is a DC coupled feedback amplifier. DC coupled feedback differential amplifier. Okay. Now we also studied some important parameters or characteristics in SYBSc. Remember that OpAmp having very high gain, that is an ideal OpAmp having infinite gain. It is also having high input impedance. What is impedance? Impedance is the reciprocal of resistance. So OpAmp have high input impedance and low output impedance. OpAmp can amplify signals having frequency in the range 1 Hz to 1 megahertz. OpAmp has ability to do mathematical operations like adder, subtractor. We are already studied it in SYBSc. It also having ability to do mathematical operations like subtractor, integrator, differentiator. Okay. In analog computers, the OpAmp have variety of other uses or applications such as a comparator, then pulse generator, then square wave generator, and schemic triggers, etc. Okay. Now we are going to briefly review the syllabus which you already studied in TYBSc, and then we are carry out the syllabus further. Block diagram of OpAmp. The block diagram, here we are going to see the block diagram, symbol, block diagram and symbol of OpAmp. The block diagram consists of three important blocks. First important block is input stage, which consists of a DC coupled negative feedback differential amplifier. DC amplifier. It has two input 1 and input 2. In between these two, input voltage is supplied. Then next block is gain stage. That means enhance the input. And then next stage is output stage. Okay, and then there is a output. This is fitted in a single silicon chip. Okay. Now the top view of pin diagram of IC 741 is shown in this figure, or this figure illustrates the top view of IC 741. This is 8 pin IC, and inside this IC there is an OpAmp. Pin number 1 is offset null. Pin number 2 is inverting terminal. Pin number 3 is non-inverting terminal. Pin number 4 is positive VCC. Pin number 5 is offset null. Pin number 6 is output. Pin number 7 is what? Positive VCC. And pin number 8 has no connection, that is ANC. This is a very simple diagram. Now the symbol is usually like this. I am again going to draw the symbol. Here this terminal is non-inverting terminal, this is inverting terminal. That is, this is pin number 2 and this is pin number 3. Okay. Now for its operation, minus volt is required, which is given to pin number 4, minus V, pin number 7 plus V, and the pin number 6 output. Okay. This is the very important diagram in order to illustrate the, or in order to show the symbol of OpAmp. Now we are going to study some important parameters of an ideal OpAmp. Here you know very well there are number of parameters which are possessed by an OpAmp, and some of them is studied by yourself in TYBSc level. Till we are going to see some important parameters, and at that time we have to assume an ideal OpAmp. The ideal OpAmp is assumed to have some ideal characteristics or ideal parameters, and these are nothing but, first one is input impedance. Input impedance. An ideal op-amp. First of all, we are going to see the parameters of an ideal op-amp. And later on, we are going to study the parameters of practical op-amp. Okay, ideal op-amp and practical op-amp. First parameter or first characteristics of ideal op-amp is that ideal op-amp has infinite input impedance. Infinite input impedance. Impedance is the reciprocal of resistance, and input impedance of ideal op-amp is represented by Zi, and this is always infinite. This ensures that no current flows into the amplifier input terminal. For this purpose, consider a diagram. Suppose this is okay. Now here I2 is equal to 0 and I1 is equal to 0. Okay. Then difference between these two input terminal voltage difference is 0. This is V1 and this is terminal V2. Okay. And here is the output. Okay. See this figure. In this figure, from this figure, I1 is equal to I2 is equal to 0. This ensures that what I say, we are going to see or we are going to study infinite input impedance. This is the first characteristics of an ideal op-amp. Ideal op-amp having ideal op-amp having input impedance as a infinite, or in a simple way we can say that there is infinite input impedance at input. Okay. And when input impedance of an ideal op-amp is infinite, that means no current flow, or that ensure that no current flows into the amplifier input terminals. And figure shows I1 is equal to I2 is equal to 0. That means what? When input impedance is high, then there is a need not necessary to do external work in order to supply the input. Means any source can drive it and there is no loading on the driver stage. Okay. Then second, output impedance. Output impedance is 0 of an ideal op-amp. Output impedance of an ideal op-amp is 0. That means what? This ensures that the output voltage of the op-amp remains the same irrespective of the value of load connected. Whatever may be the load connected to the output, but output remains 0. That's why it is so, because the output impedance is 0. Then infinite third characteristics or third parameter, voltage gain. An ideal op-amp is having infinite voltage gain, AV is equal to infinite. Hence, input difference, that is VD, is equal to V2 minus V1 or V1 minus V2 is equal to 0. Okay. Then offset, voltage and current offset. In case of an ideal op-amp, 0 voltage and current offset is there. And when voltage offset and current offset is 0, it ensures that when the input signal voltage is 0, when the input signal voltage is 0, the output signal will also be 0 regardless the input source resistance. Very important. What I say, 0 voltage and current offset ensures that when input signal voltage is 0, the output voltage signal will also be 0 or also be equal to 0 regardless of the input source resistance. Okay. Then bandwidth. An ideal op-amp have infinite bandwidth. Infinite bandwidth. What is bandwidth? Bandwidth is always related to amplifier. The term bandwidth is always connected to amplifier. What is bandwidth? Bandwidth is nothing but the range of frequency over which amplifier performance is satisfactory. There is a wide bandwidth, narrow bandwidth. Okay. What is bandwidth? Bandwidth is the range of frequency over which the amplifier performance is satisfactory. The bandwidth of an ideal op-amp is infinite. Bandwidth of an ideal op-amp is infinite. This ensures that the gain of op-amp will constant over frequency range from 0 to infinity. There is a wide bandwidth, infinite bandwidth. Infinite bandwidth means the bandwidth of an ideal op-amp is infinite. This ensures that the gain of op-amp will remains constant over the frequency range from 0 to infinite. So, op-amp can amplify DC direct current as well as AC signal, direct signal, DC signals or AC signals. Then next parameter or next characteristics, that is CM common mode rejection ratio. The common mode rejection ratio of an ideal op-amp is what? Infinite. What is common mode rejection ratio? What is CMMR? An ideal op-amp having common mode rejection ratio is infinite. And first of all, we should know what is common mode rejection ratio. You already studied this terminology in TYBSc electronics. Common mode rejection ratio is the ratio of differential gain to common mode gain. This is the CMRR. Common mode rejection ratio is the ratio of differential gain to common mode gain. Okay. An ideal op-amp having CMMR, CMRR is infinite, which ensures that 0 common. Infinite means when CMRR is infinite, that the time differential gain upon 0. Then and then, when common mode gain of common mode gain, that is difference between these two input terminal, when common mode gain is 0, then and then the CMRR, common mode rejection ratio of an ideal op-amp is 0. Sorry, infinite. Okay. And this is due to this common mode, then noise output voltage is 0 for an ideal op-amp. Then next term is very important, next characteristics is very important, the next parameter is very important, which is that character slew rate. slew rate. Which is denoted by SR. What is slew rate? Slew rate is defined as the maximum rate of change of output voltage per unit time. Output voltage is V0 and the V0 by dt is here. The slew rate, that is SR, is defined as the maximum rate of change of output voltage per unit time, that is dV0 by dt at maximum. And these slew rate are always expressed in terms voltage per microsecond. Change in voltage dV0 and time microsecond. This is the very important parameter of an OpAmp, that is slew rate, and slew rate is defined as the maximum rate of change of output voltage per unit time, and this is expressed in voltage per microsecond. When the input voltage applied to the step type which changes instantaneously, then output is also must change rapidly as input changes. Even though there is small change in input voltage, there must be large change in output voltage, and this is nothing but the slew rate. Remember that if output does not change with the same rate as input, then there occurs distortion in the output. That means that OpAmp does not work properly. Okay. Such a distortion is not desirable. Okay. And infinite slew rate indicates that output changes simultaneously with the change in input voltage, and this is the better or ideal OpAmp. Then next parameter or next characteristics of an ideal OpAmp is PSSR. Power supply, PSRR, CMRR like PSRR. Power supply rejection ratio. What is power supply rejection ratio? This is very simple. This is also ratio. PSSR is also a ratio into voltage, change in offset voltage, change in supplied voltage, and this is nothing but PSRR. PSRR, power supply rejection ratio, is the ratio of change in offset voltage to change in supply voltage. So change in supply voltage alters the operating point of the transistor inside the OpAmp, and this in turn induces a change in offset voltage. So during practical we have to null the offset voltage and we have to also null the offset current. So supply voltage change, PSSR, power supply voltage, supply voltage change is expressed in terms of power supply voltage change. That's what the supply voltage change is always expressed in terms of PSRR. Okay. Some manufacturer gives the separate PSSR in terms of VCC and VCC and VEE also. Okay. And this is expressed like this: PSRR is equal to delta V OS upon delta V supply at maximum maximum CC, or we can say that VCC constant at constant VCC, and also PSRR is equal to delta VOS upon delta V supply at VEE constant, and this is provided by the manufacturer, okay, in their data sheet. This power supply rejection ratio is always expressed in millivolt per volt, millivolt per volt, okay, or microvolt per volt. An ideal value of PSSR for an ideal OpAmp is 0 microvolt per unit volt. Okay. Now we will see the difference or correlation, or we are going to summarize some characteristics, important characteristics of ideal OpAmp as well as practical OpAmp along with their symbols. See here, sometime it is better to study the ideal parameter or ideal characteristics of an OpAmp, that is IC 74 ohm, with the practical values and vice versa. So here we are going to see the comparative study or comparison between ideal and practical value of the ideal and practical parameter of IC74, that is OpAmp. First parameter, open loop gain. Open loop gain. Symbol for is AOL. A is symbol for gain and OL stand for open loop. For an ideal OpAmp, this open loop gain is infinity, whereas for practical OpAmp, this is not infinite, but this is nearly equal to 2 lakh. Okay. Then output impedance. That is ZO. For ideal OpAmp, this is 0, but practically it is found that it is not 0, but it is very low, that is 75 ohm. Okay. Then input impedance, that is symbol is ZI or ZIN. Practically it is, ideal, we seen that the input impedance of an ideal OpAmp is infinite, but practically it is nearly 2 mega ohm. Okay. Then input offset current, that is IOS. Ideally it is 0, but practically it is very, very small, that is in 1 to 2, not 1 to 2, nearly 20 nano ampere. What I say, input offset current, practically 0, but ideally 0, but it is practically found that it is nearly equal to 20 nano ampere. Okay. Then input offset voltage. This is one of the important parameter, that is VIOS. OS stands for offset, input offset voltage. This is ideally 0, but practically it is 1 to 2 millivolt, very little. Okay. Then bandwidth. Symbol for bandwidth is BW. Ideally it is infinite. But practically it is 1 up to 1 megahertz. Then common mode rejection ratio. Symbol is delta, rho. Ideally it is found infinite, but practically it is 90 decibel. Then slew rate. Symbol is SR. Slew rate is infinite for ideal op-amp. Infinite. Slew rate. Infinite or 0? Just a minute, I want to check. Slew rate. I told you that the slew rate is defined as the maximum rate of change of voltage, output voltage per unit time, and is expressed in volt per microvolt. The slew rate on op-amp is high but not infinite. High but not infinite. And practically the slew rate of IC7/1 is 0.5 volt per microvolt. Okay. Then input bias current. Input bias current. Symbol is IB. Input bias current, ideally it is 0, but practically it is not 0, it is very close to 0, that is nano ampere, 80 nano ampere. It is nearly equal to 0, nano 10⁻⁹. Then power supply rejection ratio, PSRR. Practically it is 0. Ideally it is 0. Ideally 0. But practically it is very low, that is 30 microvolt per volt. And last, power consumption. Power consumption. Ideally an op-amp consumes 0 power, but it is not true. Practically it is 50 millivolt power is consumed by an op-amp. These are the parameters or characteristics of an ideal op-amp along with their symbols, and practical and ideal, or ideal and practical. Remember that the characteristics of an ideal op-amp can be closely enough for many practical op-amp. Practically they have an open loop gain which is very large, open loop gain I told you, but it is found that it is in the range of 10⁵, that is 1 lakh to 9 lakh. Okay. They have large but infinite input impedance. Though it is theoretically infinite, but it is practically large. this can be marked, this can be marked on, sorry, this can cause a mark effect on the performance of OpAmp application, particularly when it is used in application involving frequency dependent performance parameter. Okay. You have to summarize all the practical and ideal, sorry, you have to summarize all the parameters or characteristics of an ideal OpAmp and practical OpAmp